Check. Okay, you're able to see the screen, right?
Yes.
Yeah.
Okay. So now we will understand, as we discussed previously. So this is an office area which is located in Bangalore, and I've given the following details, which is what are the slab. That is nothing but the height, the clearance between your floor and the slab is the bottom of your slab, which is 13 feet height. And then you have got beams across the section because obviously when you have this office, you'll have beams and columns, right? Which I didn't mark it, of course, but you'll have beams. So I'll consider like 1 feet 300 mm is the height of the beam. So 12 feet is bottom of the beam, and bottom of the fall ceiling is 9 feet. And I've got indoor conditions which I want to maintain is 23 degrees centigrade and 50% RH. Here. And above floor, I've clearly given it's air conditioned space. So if your above floor is AC space, will there be any heat transfer? From the
Yes.
top, will there be any heat transfer to the down or not?
It will.
Yes,
Yes or
it
no?
will be.
Why? Because
Yes,
above floor is also air conditioned, I've given. So if above floor is AC, why will
no,
there be any heat transfer?
temperature,
There is AC, there is no.
temperature.
If it is AC, it is not. It will not transfer. Always
It will not
lower
transfer,
to
that's what.
high.
So above floor is AC means there won't be any heat transfer. Below floor, I've given that it is parking area. So if it is non-AC space, will there be any heat transfer to below floor?
Yeah.
Yes, right, obviously. So we'll have for below floor, there'll be certain amount of heat transfer. That means let's make it as a block. So in our case, it's something like this. So this is a three-storied building, let's say. So you are working on the central one. Below floor in non-AC means obviously heat gets transferred from top to bottom. Above floor is non-AC means there won't be any heat transfer. So above floor, you can consider as it's air conditioned space. There won't be any heat transfer on the from the top. Only from the bottom you'll have heat transfer in this project. Clear?
Yes.
Mm,
Okay. So these are the windows. So as I've told you, this is the directions I've given. So this becomes north, this becomes south, this becomes east, and this becomes west. To avoid confusion, I'll mark the directions. North. So this is your north, this is your south, this is your east, and this is your west. West. Okay. So for this, we'll be working on heat calculations. So rule number one. You'll always consider heat load or you have to calculate heat load for summer conditions. Because if you're able to satisfy a client in summer, don't you think during other seasons people will be happy with the air conditioning solution?
mm,
Yes.
Yes or no?
yeah.
Yes.
So for that reason, we always design it for the worst day situation. So I'll be explaining about the probability of worst situations and all later on. Let's not complicate at this point of time. So we will take summer condition, number one. Number two, we'll always consider at evening 4 p.m., which is generally peak for your heat accumulation inside the room space. The reason why we say 4 p.m. is, unless your building is probably with a glass. Okay, the reason why we say at 4 o'clock is two things. First and foremost thing is 99% of the time, not even glass, whether you have block work or glass also, 4 p.m. is a worst case situation. The reason is, when do you think you have highest temperatures in a day? At what time?
Afternoon, evening.
Afternoon, 2 o'clock like that. You agree?
Mm, yeah.
So if your building is made with the brickwork, don't you think it will resist to certain time? Or the minute you have a heat, does the temperature comes into your room space? Don't you think it will hold heat for some time?
Yeah.
The block work,
Is it not?
whatever is there inside the rooms, what you constructed with, don't you think it will when the photons hit the surface, it will localize, it gets heated up, it will take some time to dissipate into your room or not?
Yeah, it will.
Yes.
It will. So that will approximately be 1 to 2 hours because 2 to 3 you have highest sun. So 4 o'clock we'll always consider as a worst condition. 4 p.m. will always consider the highest amount of heat. Not only that, if your building is made of, let's say, glass or something, during that time also what will happen at 2 o'clock your angle of incidence is not too much, but at 4 p.m. the location of your sun. You agree? Because 2 o'clock it will be on the top. You don't have much sunlight coming into your room space. But evening 4 like that, you have a lot of sunrise that's coming into your room space. You agree?
Yes, sir.
Mm. Yeah.
Able to everyone is able to follow?
Yes.
Yeah. Yeah.
Yeah. So for that reason, we always consider 4 p.m. as a worst case situation. So if you're able to satisfy anyone at 4 p.m. summer throughout the year, 99% it should be fine. Except in few locations where monsoon have got very high amount of heat. Let's not worry about it now. But in most of the practical cases, your summer gonna be worse. You agree?
Mm.
So now we'll start working on this particular project where we will understand how to derive the heat load. So what I'll do is I'll do heat load for this office. You guys have to do it for pantry and this cafe conference room once this heat load is done. Is it fine? Fair enough?
Yes.
Okay. So now we'll start working on the heat load calculations. Okay. So Mohammed, you already know AutoCAD, right?
Yes.
Okay. So splitting the screen, hope it is visible.
Yes. Visible.
Okay. So first and foremost thing is we have to always calculate your outdoor conditions. Okay. So because for every formula, don't you think you were using delta T or delta humidity ratio? So for that reason, you have to calculate what is the temperature difference and moisture content between indoor and outdoor. Clear? So first we'll calculate uh, ODC. I'll do one thing. This I'll write it as dry bulb temperature. After dry bulb temperature, what is it? It's wet bulb temperature. Then it will be your relative humidity. Then it will be humidity ratio. Humidity ratio. This is your ODC outdoor conditions. This is your IDC indoor conditions. Is it fine? So first and foremost thing is indoor conditions is 23 degrees centigrade. But what we were using till now is Fahrenheit, isn't it? So we will convert this centigrade into Fahrenheit for your indoor conditions. So indoor conditions is how much is it? 23 degrees centigrade, 50% convert into Fahrenheit. So C is equal to 5 by 9 into F minus 32, or you can always get on Google to convert into Fahrenheit, which is simple, but let's convert it manually. So C is equal to 5 by 9 into C is equal to 5 by 9 into F minus 32 is a formula. Understood? So this is a formula that we'll be using it. So now I have C value, I have to convert into F. So C is equal to, I can make it as 9 by 5 plus 32 or not? Hello? So
Yeah.
C value is 23. So if I want to convert it to Fahrenheit, what I can do, I can always do it by is equal to 23 into 9 divided by 5.
Divided by
I'll
5.
add additional brackets just for the
Plus
safety.
12.
Plus 32 I can do it.
Plus 12.
Plus 12.
Mm.
So 73.4. So that's my Fahrenheit. You agree? Then coming to the wet bulb temperature. We have to calculate it anyway, and I've given relative humidity is 50%. Now, don't you think using these two, I've already taught you in psychometrics, using this dry bulb and RH, don't you think we can calculate wet bulb and humidity ratio or not?
Yeah.
Yeah. Okay. If you
Yeah.
remember, psychometrics have uploaded in the group, right? Oh, no. Yeah. I've
Mm.
uploaded this in the psychometric chat, right? So save as, I'll try to save it in the civil file so that at a time I'll actually able to share it with you. August, right? Yeah, psychometric chart. Or you have anyway, you have even this thing as well. You always have your what do you call app to calculate it, which I'll be sharing you know by. So we can use these two parameters to calculate your enthalpy, humidity ratio, all these parameters, isn't it? So let's calculate it. Okay, so what we require is this particular chart. I'll open it MS Paint or AutoCAD. I'll do it so that I'll be able to mark it if that's okay for you. Just a second. This is files. Okay, I'll open a new file in which I'll import this one. Please, all data, personal training. Oh, there's no psychometric this thing on there. I'll do one thing. I'll open that file. Just a sec. So I'll open this psychometric chart. I can use like AutoCAD means I can draw a line, whatever I want. That's the reason. So what is the temperature? What is the temperature?
73.4. 73.4.
Yeah, Excel vertical 73.4. So this is 1, 2, 3, 73.4 is roughly this one. The pink color line, if you could see. Yes or no?
Yeah.
Width 25. The line. Width 100. Is it visible for you guys or not? The line that I've drawn it. Pink
Yes.
color one.
Yes.
Yeah, visible.
Okay, so this is the 73.4 line. I've got it. 171, 72, 73, 73.4. Perfect. And now, don't you think the relative humidity is how much? 50%. So I can
Yeah.
see what is 50% exactly. So don't you think this guy is 50%? So I'll just draw a circle over here, which is intersecting. Sorry, H. Select the subject. So don't you think this particular dot is my my psychometric point or not? This red color dot which I've drawn. Is it visible? Hello?
Yeah.
Visible, sir.
Yes or no?
Yes.
Visible.
Okay. Now I can calculate the other things, which is, so I require dry bulb temperature. I got it. Now I want wet bulb temperature exactly not required. But its humidity ratio is important, isn't it? So we'll calculate the humidity
Yeah.
ratio. So humidity ratio, how will we calculate? Just by simply drawing a horizontal line?
Yeah.
Yes or no? So humidity ratio, I can directly
Yes,
draw
yes.
Excel vertical, sorry, Excel H will calculate. So this will directly give us the humidity ratio. So humidity ratio, how much I got it? This is basically grains per pound, which is correct for us. So this particular value, if we take it, so this is 60, 62,
62, 3,
because each decimal, let's say only 5 decimals are there, so 62. So probably 62.5 or something,
62,
right?
62.4. Oh, yeah. Yeah.
Yeah, because it's not in the center, or else I might have taken 63. So this is 62.2 or 62.5. So I'll take 62.5. 62.5 as my humidity ratio. Understood or not?
Yes.
If you want to calculate the wet bulb, it's simple because already this is exactly following over one line. So 61 degrees approximately your wet bulb temperature. 61 is your wet bulb temperature. All the units are in degree Fahrenheit. You agree? And this is grains per pound are the units of it. So I'll write the units of it in the brackets. Fahrenheit and degree symbol, I have to insert it. Just a sec. Insert symbol. Insert. Close. So this is degree Fahrenheit. Wet bulb also is degree Fahrenheit. And relative humidity ratio is grains per pound. Grains per pound. So let's go back to your this thing. Okay. So now I can directly take outdoor conditions or not? Yes.
Yes.
So for that, yesterday I've already shared you one file data. You remember? All data to read or something. Don't matter. This sheet I've WhatsApped you if you guys remember. Yes.
Yes. Yes.
Okay. Outdoor conditions is not there. Just a sec. I have a separate thing called weather data. Weather data, design jobs. Yeah, weather data. So this is data for heat load. Okay, in this also is the same thing anyway. Uh, and along with that, we have your outdoor conditions. So this is your outdoor conditions old data. So currently we'll work it with old data because this is easier. Later on, I'll explain you an ASHRAE link, whatever I've shared you. So I'll share you these two links as well. Just a sec. Sharing all the data in the group itself. You can download this. Okay. So now if you see your outdoor conditions, what is the state? Karnataka alva? Bangalore means.
Bangalore.
Bangalore. So if you see this particular condition, you can see summer dry bulb, wet bulb RH. You can see for Bangalore condition, the temperature is 96 is dry bulb, wet bulb is 78 and 45% is RH. You agree? 96, 78 and 45. So outdoor condition is 96 degree Fahrenheit. Wet bulb is how much? 78. 45 for summer. So we can take these values and we can obviously calculate your humidity ratio or not. So we will try to calculate the humidity ratio. So if you wanted to calculate humidity ratio, we can always use this particular one. So now what is the temperature? 96, right? So I'll move this line from 70 to 96. So 80, 91, 92, 95 is this, and this is 96. So I can take this line. Yeah?
Yeah.
Okay. This chart itself is not straight. So I have to mark it like this. Yeah, I have to mark it on the line. There's a slight deviation. Anyway. Then coming to the next one is 45% RH. Plus RH is kind of tough. Don't you think I can make my, like, this one, which is your wet bulb temperature 61 or not?
Hmm.
Can I make 61? Wet bulb temperature, which is, sorry, not 61, 60, 78 alva for outdoor condition for Bangalore. Yes or no? So I have to take it 78. 78, I'll do one thing. I'll just draw a line at this location. One more 70 line, where is it? That location I'll draw and then I'll move it. Oh, sorry, I guess this is an ortho. This is this is your wet bulb line. Yes or no? Yeah. So this line, don't you think I can move it to 78, right? So I'll move it to 78. 70. So 70, 71, 72, 75, 76, 77, 78. Don't you think this will be the value?
Yeah.
So if I intersect that, okay, this line is exactly not because of this which is not good. Anyway, it's on 90 degree, that's the reason. So this is a point, this intersection point or not? So this node, I'll directly take it.
Yes.
This intersection line, I'll directly take it. So this, I'll take it a horizontal line from here. Use ortho again. So from here, we'll take an additional line. So here, the moisture content is somewhere around 110, 112, 114, 116, somewhere around 118. I can, so it's just
118.
below 118. So I
118.
can consider 117 or something.
117.5.
Yeah, 117 approximately should be fine. Or 117.5 also it could be. So 117.5 round it off. Okay. So this is our humidity ratio. So we got your outdoor conditions. Now what we can do, we can calculate the difference values, difference or the delta values. So dry bulb temperature, outdoor minus indoor will be your delta T. Wet bulb we don't require, and humidity ratio delta HR we have used it in the formulas right yesterday. This minus this. So automatically we'll get these values. Understood or not? So this is a delta T value and this is your delta humidity ratio. We use it as per our requirements. Am I clear?
Yeah. Yes.
So now what we'll do is we'll start working on the equations. So first and foremost thing is, as I've told you, understanding your project is quite important. So I'm just closing this window. Now we have to understand. See, out of this project, out of this, I've clearly said this is a separate AC, this is a separate AC, and a server also will generally use a separate AC. So I like to give this also as a separate AC. Okay, so these three are separate. I've got it. Okay, now I want to do air conditioning for the remaining area. Don't you think I'm supposed to calculate the area? How much area I have to do air conditioning or not?
Yes.
So for that reason, we will use polyline command and we'll do it. So I'll write it as heat load, I'll add it. So for this, we will calculate our area. So obviously it's a separate AC, so I don't want to include it. So this is our area that I have to air condition. Obviously, toilet is non-AC space. Server is also non-AC space, I mean separate air conditioning space. So I need not worry about that. We have to worry it separately. You agree?
Yeah.
And pantry is also separate air conditioning space. So all these is inclusion. So don't you think this is the total area that I have to air condition or not?
Yes.
This is the total air conditioned space I have to do it, right? So let's calculate this area. So we just use list command. So you'll know the area, which is how much? 5,900.3 SFT, right?
Yeah.
So area to be air conditioned is, so all this data I'm marking it, area to be air conditioned. How much is it? Area of ACL, right?
5,000.
AC is how much? 5,000 point? 5,900.32 SFT. So shall I roughly make it as 5,900 SFT?
Yes.
Yeah.
5,900 feet square. Feet square. Feet square. So this is the total area that I've got it. This is area. Area for air conditioning, right? So then now coming to the next one is what is the this thing, each direction we have to calculate. Sensible heat gain due to we have to calculate the following things: sensible heat gain due to exposed wall, exposed glass, partition wall, all those things you remember, right?
Yeah.
So we'll calculate with those.
Yeah.
Just a second. Just a second. So we'll be calculating on the following things. So first of all, we'll write on sensible heat gain due to exposed wall. All those things we'll start writing. So sensible heat due to exposed wall. Due to exposed wall. Exposed wall. So only my advice is after this lecture, you'll get the video, right? Just go through it and you try to make a note yourself so that you'll be clear. Okay. So sensible heat gain due to exposed wall. Heat gain due to exposed wall. So first we have to. So which all directions are there? North, east, south, west. All the directions I've got it. You agree? So here I've got a wall. All the directions I've got wall. Yes or no?
Yeah.
So what we'll do is basically we have to calculate north side, east side, west side, south. All directions we have to calculate the heat load. So for that we'll start with the north direction. So this is a north direction, right? So in this I'll write sensible heat gain due to north wall. It's already I've written on the top of the walls. I'm not writing a wall on all the directions. So for that, what is the equation? Q is equal to U into A into delta T plus CTD. You agree? It's just a symbol. Correction in temperature difference, CTD. Yeah. You made a note yesterday, or you want me to illustrate what is everything you want me to give it here again?
Not right.
Not required, no? Okay. So yesterday we already had a discussion. So U factor is nothing but the quotient that we discussed yesterday. Amount of heat transfer per unit cross section area per unit time per unit temperature difference. A is nothing but your area. Delta T is equivalent temperature difference, and CTD is correction in temperature difference. So now let's go through the data and we'll try to get these details. Okay. So we'll open this. So in this data sheet, I have to just search. It's been many days, probably years that I've taught this heat load manually to someone. So just a sec, I'll go through it once. Yeah, this is your for brick wall and all. Veneer walls, masonry walls. Yes. So I'll give you the page reference number also. You can go to page number 15. Okay. So U factor, you get it from page number 15. Okay. So here, according to our wall thickness, we have to take. Clear? So let's consider my wall thickness is somewhere around some 8 inches thick wall. Okay. So if I consider 8 inches thick wall, what I have to consider is these two things. One is basically face in common. So that means you have face in common means basically you have plastered on both the sides. One side is face, other side is common. So I mean, base basically you have plastered it, not raw finish. So considering all those things, let's say we have 5/8 the plaster with sand aggregate. We have got 5/8 the plaster of sand aggregate. So if you have done plastering, then what is the U factor over here? We got it 0.45. Hello.
Yes. Yeah.
So according to the material, you have different kind of material. So according to your material, hollow block work you can choose. According to your type of material, you have to choose your U factor. Am I clear?
Yeah.
So we'll consider basically face in common, and this in which a 5/8 the plaster on the wall with a sand aggregate material, and this is basically 0.45. So U factor we got it from 0.45. U factor is U is how much? This I'll write it as U. In here I'll write page number 15 alva. Okay, page number 15. So
Yeah,
how
15.
much is that value? 0.45. I'll write the reference so that for you to remember. Here I'll write the units as well, which is BTU per hour per feet square per degree Fahrenheit. So BTU per per degree Fahrenheit. I'll copy the value per R per degree Fahrenheit per feet square. You agree?
Right.
So this is nothing but the units of our U factor. Clear? Then coming to the next one is, so this is U factor is done. This is 0.45 is the value, and these are the units that I'm putting. Now, don't you think you have to calculate the area?
Yeah.
Area. So what is area over here? So area is equal to, don't you think your area is nothing but your length into height or not?
Yeah, length and height.
Length into height. So this length is how much? 30 feet, right? Height is how much? I've already given part of the slab is 13 feet. So don't you think
Mm.
area will become 13 to 15, 13? 13 to 13 or not?
13 to 13. Yeah, 13 to
13.
13.
Minus, I have to remove the glass which is present over here because this is not a part of a wall, right? Glass will calculate it separately. Alva?
Yeah.
Yes.
So area is equal to, how will you calculate it? So area is equal to width into height minus window area if you have any windows. Yes or no? Minus windows or glass areas, minus glass area.
Cross area.
So area is equal, sorry, area is, how will you get area is equal to, in our case, it is 30 into 13, that is width into bottom of the slab, minus of glass area. Glass
Glass
area
area.
is 15 to 8, Alva.
Oh,
15 is
yeah,
the length
15
and
to
8 is the height, is equal to 15 into 8. Understood? So
yeah.
my effective area of the wall is 270 square feet. You agree?
Mm.
Then we have to calculate your, I'm writing each and everything. The reason is it will be easy for you to, when I share you this Excel sheet, for next equation onwards, I'll not read it directly, I'll solve it and I'll just show it there. Is it fair? I mean,
Yeah.
you're able to
Yes,
understand, right?
yes, yes, yes,
Okay.
yes.
Then coming to delta T. So let's copy this delta T. So delta T is what? It's nothing but equivalent temperature difference. Equivalent temperature difference. So this delta T, you will get it again from, you'll get it from certain page number, which is, we'll try to figure out. So delta T is equivalent temperature difference. So equivalent temperature difference, you will get it from this particular value, which is for dark color or sunlit or shaded roofs. This is for roofs. This is for dark color or sunlighted walls. So this we can calculate. But for that, you should get this one also. Weight is also important. So if you remember, there's a thickness. Hey, by the way, small thing actually. What is the width of a wall? 6 inches we have considered, so that's okay. That's okay. 8 inches we have considered. So the value is how much? 87. Weight of the wall is
87, yeah.
87. You agree?
Yeah. Yeah.
Okay. So we'll take this particular one to this guy over here, 87. So this is equivalent temperature for dark color sunlight. Though it's light color, we will design it for dark color so that we'll be safer anyway. So for this, we have to calculate. See, I've told you already, we will get it for 40° north latitude. We'll correct it afterwards. That's the reason we use correction temperature difference anyway. So summer, we have to consider. And what is the worst case? What time is the worst that will
4 p.m.
right? So what we have to do is we have to consider what is the direction north. North 4 p.m. we'll take it. So we'll take north as your 4 p.m. We'll take it. So this is your 4 p.m. north. And this value is 10 and 4. For 100, the value is 4. For 60, the value is 10. You agree? Yes
Can
or
you
no?
repeat?
For 60, the value is, I'll try to draw this just a sec. I don't know whether I can. Okay. So this value you can see it. Intersect these 2 points. You agree? So if you do it, don't you think for 60 you got 10 and for 100 you got 4 or not?
Yes.
Okay. So for that, now what we have to do, we have to calculate for and 4 we have to take it. So we'll do interpolation.
Yeah.
For 60, what is the value? That's 10.
10.
For 40, what is the value? For 100, what is the value? 4.
4.
What is the value we require?
Mhm.
Weight of the wall, we've seen it, right? Because it depends on the density of the
80.
material. 84 or something, 87. So our value is 87. You agree? We have to make a note of this parallelly. So this is 87. So for 87, I require it. 87, I require it. So which is obviously 87 alva. I'll write it over here, 87. So is equal to this minus this. Control C, Control V. So for 60, 10, for 100, it is 4, right? Okay. So is equal to 40. For 1, how much it will be? Is equal to minus 6 into 40. Sorry, minus 4 divided by, my mistake, divided by 40. So it is minus 0.15. So 87, I can always write it as is equal to 60 plus 80, 80 is equal to 60 minus 87 is how much? 27. So is equal to 60 plus 27, I can write it is equal
Yeah.
to 10 plus yesterday I already taught you into this value minus 0.15. So automatically it will be 5.95 as a value. You agree?
Yeah.
So equivalent temperature difference I got is 5.95. Yeah, this is our equivalent temperature difference. Understood or not?
Yeah.
Okay. Then coming to the next one that we have is, then we'll be calculating the next element, which is your, after this, we'll be working on, shall I leave it? U factor? I mean, interpolation.
Let
Then we have something called a CTD, which is again your correction in temperature difference. Correction in temperature difference. So the CTD we will calculate it now. So CTD is simple. CTD is equal to correction in temperature difference. So correction in temperature difference, we will get it using 2 parameters. I'll go through that. I'll explain you that once again. Just a second. Yeah, this is your correction temperature difference. Correction temperature difference depends on 2 things. One is daily range temperature and other is outdoor minus inside, which is your delta T value again. Clear? Daily range temperature is nothing but your maximum temperature of the day by minus minimum temperature of the day. That also you get it from outdoor conditions. For Bangalore, your this value is daily range. You can see it in degree Fahrenheit. You can see it on the top. Yes or no? So this daily range, if we consider for Bangalore, is 22. So daily range temperature is 22. Daily range temperature is 22. You don't get the data. I mean, you don't have anything for indoor, obviously. Right. So your daily range is 22 degrees Fahrenheit. Now what we'll do is we'll calculate the CTD value. So you know that daily range is 22. Luckily, 22 number is available or not?
yes.
Right, luckily it's available. So we need not interpolate much. But then indoor minus outdoor condition. Indoor minus outdoor is how much? 22.6. You agree? So 22.6. So you have the value for 20. You have the value for 25. So don't you think you can calculate for 22.6 or not?
Mm.
We have to interpolate again. So for 22, the value 20, the value is 4. So for 20, the value is 4. But whereas for 25, the value is how much?
9.
9. For 25, the value is 9. You have to calculate for 22.6. 22.6. So is equal to, again, say formula, I'll use it. Control V. So for 1, the value is 1. So 22.6, I can write it as 4 plus 1, 4 plus 2.6 or not? 20 plus 2.6, one value is anyway 1. So I can add directly 2.6 to this. So automatically my CTD will become 6.6. Understood or not? Able to follow?
Yeah,
Page
yeah.
number 14. Page 14. Write it. So this also I'll write it in page numbers. Page 14. Yeah. So automatically the value is 6.6. The Q value, I can directly write it as Q in BTU per hour, BTU per hour, or I'll write the unit separately, right? So anyway, Q will directly take it. So Q is equal to U into area into delta T plus CTD, delta T plus CTD. So this gives me this is nothing but your BTU per hour, BTU per hour, and units are really important. Feet square. This is feet square. This is degree Fahrenheit. This is also degree Fahrenheit. So this is, I can write it as equation A or
Yeah.
equation 1, I'll write it. Is it okay?
Mm. Yes.
1A, I'll write it. 1A, I'll write it. So this, I'll write it as equation 1A. Okay, 1A. This is equation 1A, I got it. Understood or not? Yeah.
Mm.
Then we will again calculate sensible heat gain due to north is over. Now, don't you think we have to do it for east, west, and other directions? So we'll calculate for east or not?
Mm.
So we'll calculate for east. So in this, Q is equal. So I'm not going to deal I'll not tell it. I'll not mark it individually. I'll directly write it. So A value we can directly calculate it here. So A value is nothing but how much is the area? This length into height or not? So this is the length we got it, which is 29.8 inches is not 0.8 is equal to 8 by 12. If you do it, that will 0.66. 0.67 will rate 29.67 is equal to 29.67 into 13 feet is your bottom of the slab. You agree? Minus, don't you think you have to remove the windows or not? So I've got
Yes.
25
Yes.
square feet,
Windows.
3 such windows. Minus of 3 into 25. Alva? Because each one is 5 5s are 25 square feet. So I've got 3 such windows in that particular area. So considering this 3 times square feet, this into this into height minus 5 into 5, I've done it. So we got this value. So this is nothing but your area of exposed wall in east direction. Then coming to delta T. Delta T will again get it from the data book. We'll get it from the data book. So this data book, let's go back to page number 14 again. So this is this value. So what is this? And now I have to, don't you think you have to calculate your delta T value? U factor will be same anyway. Okay. Alt I C, sorry, Alt I R. Okay. Your U factor, don't you think you will use same brick or will use a different bricks according to the directions?
Same brick.
Same brick. So obviously U factor will not change, right? But delta T will change because of the orientation. So delta T, if you see, what is the direction that we got it? What is the page number? Delta T is
East.
page number 14, right? So equivalent temperature difference. So equivalent temperature difference. Now, what is the direction we have to take it as? East direction. See it at 4 p.m. if we do it, 60 you know, 100 you know. Don't you think we can always calculate for the value that we wanted? Yes or no?
Yeah.
Yeah, for 60, the value is 12. For 100, the value is 18. You agree?
Yes.
Yes, just a second. Square. When it increases, somehow it's decreasing, but that's okay. Okay. So for 60, the value is 12 OPM. If you take it, for 60, the value is 12, right? For 100, I will copy these values over here. For 60, what is the value? East direction? 12 alva? 12 and 18. This is 12 and this is 18. So we'll copy these formulas. This is positive actually. It's weird. But anyway, for 1, the value is equal to this value divided by this guy. You will get 0.15. Now, what is the value that I require for? 87, right? Same density. Yes or no? So this
Yeah.
value is nothing but 27, 60 plus 27, obviously. 27 to J23 is this, what is J23? J23. So automatically it will be 16.05. So this value is 16.05. You agree? Yes or no?
Yeah.
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 Then coming to correction in temperature difference, which is constant irrespective because it's not dependent on the direction, right? It depends on the location and your place is in Bangalore. So automatically the correction temperature difference and your indoor conditions is also same. So your CTD will be same. So now again, we can calculate Q is equal to, I mean, if this thing is same, then I'll get the same answer. Let's say, okay, here there should be some equation. So it's not B19, it's B22. Okay, 22 into area is how much? Area is this one, and delta T. Okay, just a sec. Is equal to U is how much? U into area into delta T plus CTD. Delta T plus CTD. So automatically you came to know this particular one. This I'll write it as equation 1b. Yes or no?
Yeah.
Then coming to the next one that we have is sensible heat gain due to expo. We'll complete the walls today. From tomorrow, again, tomorrow we'll continue with glasses. Tomorrow we'll ensure to complete because tomorrow anyway it's holiday for me. So I can extend even post 7 o'clock. So at least we'll complete tomorrow the entire heat load calculation. Is that okay? Hello?
Yes. Okay.
Okay. So or else I'll start a bit late tomorrow. I'll start by 6 o'clock in the morning. Are you guys comfortable?
Yeah.
I mean, for
Yes,
you
sir.
officers, none of you is a problem, right? Tomorrow?
Yes. We can.
Because I can extend till 7:30 or 8 o'clock. At least I want to sleep sometime extra tomorrow. That's the reason. Is it okay?
Okay. 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 Okay.
Fine. So then coming to the next one that we have is sensible heat gain due to east is over. So north, east is over. Now we'll go with the west side. West.
Yes.
Okay. Sensible heat gain due to west direction. So again, the same formula. Q is equal to V delta T plus CTD. Now we'll go to the next element, which is nothing but your area. Area, you'll obviously get water, like, you from the drawing, you have to get it, which is this total length. Sorry, south, right? So first we'll work on south, then we'll go to west. Because in 90, like, we are going in a clockwise direction, let's go like that. So this coming to the south direction. So this is entirely your south. So in this direction, do you have any glass? Do you have any glass over here?
No.
No, sir.
No.
No, sir.
So we'll take it as a 0 glasses. So the door is there, but that's okay. We can ignore it. I'm assuming it's a solid door. So it is 69.4. So 4 inches is equal to 4 by 12 is 0.33. So that's okay. 69.4, we can take it. So 69 point is equal to 69.4 into 12 feet. Sorry, 13 feet, which is bottom of the slab. You agree?
Yes.
Then coming to delta T and U value is constant.
Yeah. Well,
U value is constant, and then we have to calculate the delta T value. We have to calculate the delta T value, and then we have to calculate your this thing as well, CTD as well. So CTD is constant. I've already told you that because it depends on temperature and this thing. So equivalent temperature difference is only thing that will change now. So equivalent temperature difference. Now we have to calculate for south direction. So let's go back to this one. So this is south. South, don't you think again I can take this value at evening 4 p.m. I can take it as 26 and 16? Yes or no?
Yes.
60 and this thing just say 60 south alva 26 and 16 I can take it, right? So 26 and 16 I'll directly take it as this value. Yeah, 26 and 16. So automatically I'll get the value which is 19.25. So this value is after interpolation 19.25. I get it. You agree?
Yes.
So this value is nothing but 19.25. You get this value. So then Q again, Q is equal to UA delta T. Q is equal to UA delta T is equal to U into area into delta T plus CTD. Delta T plus CTD. So you got this particular one, which I'll write as equation 1C. Then coming to the next one that we have is sensible heat gain due to
West.
west direction. The last orientation that we have is west. Sensible heat gain due to west. Again, we will use this equation. Control C, Control V. Yeah, area I have to calculate it. So area is simple. Again, we'll take length into width minus glass areas. So this is your total length. You got it, which is 60 feet. 60 into 13 is equal to 60 into 13. 60 into 13 minus of window area. I have to do it. So windows, how many are there? 5 into 5. 1, 2, 3, 4, 5. So I can take it as 5 into 25 again.
Yes.
655 square feet. Right. Then again, we'll calculate the U factor, which is again same. I need not worry. Delta T we have to calculate it. CTD we have to calculate it. But anyway, this delta T will change. So delta T is equal in temperature difference. We can use this this particular one. Now, what is the direction? West alva.
West. Sorry.
West it is how much?
Uh,
12 and 10. So we'll take the values 12 and 10. So this value is 12. This value is 12 and this value is 10. 12 and 10, right? Okay, for sorry, 26 and 12. My mistake. 26 and 12. 26 and this guy is 12. So automatically we'll get to know the value is 87 is 16.55. You agree?
yes.
So again we'll calculate the Q value. Q is equal to UA, U into area into delta T plus CTD. Delta T plus CTD. This I rated as equation 1D. So these are all the directions we have got it. You agree?
Yes, sir.
Now what we can do, we can calculate the total sensible heat gain due to exposed wall, which is your summation of equation 1A to B. You agree or not?
Yeah.
Right. So this is nothing but your summation of just a sec. I'll try to insert a symbol. That's it. Yeah. Insert. Okay. This is summation of 1A to 1B. Sorry, 1D. You agree? So shall I add it over here?
Yeah.
Or I'll write it at last. I guess that will be better. So sensible heat gain due to exposed wall. Exposed wall is nothing but your equation is nothing but this one plus this guy plus this guy plus the last one is okay, this guy. So all the four directions, if we add it, that will be your main equation. Understood or not?
Yes, sir.
Okay. So this I'll write it as I'll mark it as equation one. Is it fine?
Yeah.
Okay. This I'll mark it as equation one. I'll just highlight it for my ease. So this is your one of the equations that we will use it later, which is equation one. Am I clear?
Yes.
Understood?
Yeah.
So now we will calculate for sensible heat gain due to exposed glass, roof load, all the loads we'll add it, then we'll get the total heat gain due to civil structures. Am I clear till now?
Yeah.
Yes, sir.
Okay. So tomorrow we'll ensure to complete the total heated calculations. So but tomorrow I'll take my class by 6 o'clock. I hope no one has a problem, right?
Okay.
No, sir.
Vinod as well as Dikshit,
No,
Yeah.
no, sir.
even Mohammed
Can
as well.
you share that class today's class recorded class on the group?
Yes, I will. I will because in laptop
Yeah.
it's possible, right? So I'll stop recording and
Yeah.
speak. Yeah.
Fine. Fine.
So